Alright, I'm going to read from the exercise physiology book. I'm going to read page 81. This is body fuel sources, page 81. In this section, we outline the storage sites in the body for carbohydrates, fats, and proteins. Further, we define the role that each of these fuel storage sites plays in providing energy during exercise. Finally, we discuss the use of lactate as a fuel source during work. Finally! Or respectively! Or essentially! Okay, never mind. Sources of carbohydrates during exercise. Carbohydrate is stored as glycogen in both the muscle and the liver. Muscle glycogen stores provide a direct source of carbohydrates for muscle energy metabolism, whereas liver glycogen stores serve as a means of replacing blood glucose. For example, when blood glucose levels decline during prolonged exercise, liver glycogenolysis is stimulated and the glucose is released to the blood. This glucose can then be transported to the contracting muscles and be used as fuel. Carbohydrates used as a substrate during exercises from both glycogen stored. Interesting. Alright. Carbohydrate used as a substrate during exercise comes from both glycogen stores in the muscle and from blood glucose. The relative contribution of muscle glycogen and blood glucose to energy metabolism during exercise varies as a function of the exercise intensity and duration. Blood glucose plays a greater role during low intensity exercise, whereas muscle glycogen is the primary source of carbohydrates during high intensity exercise. As mentioned earlier, the increased glycogen usage during high intensity exercise can be explained by the increased rate of glycogenolysis that occurs due to recruitment of fast twitch fibers and elevated blood epinephrine levels. During the first hour of submaximal prolonged exercise, much of the carbohydrate metabolized by muscle comes from muscle glycogen. However, as muscle glycogen levels decline across time, blood glucose becomes an increasingly important fuel source. Sources of fat during exercise, page 82. When an individual consumes more energy food than he or she expends, this additional energy is stored in the form of fat. A gain of 3,500 kilocalories of energy results in a storage of 1 pound of fat. Most fat is stored in the form of triglycerides and adipocytes, fat cells, but some is stored in muscle cells as well. As mentioned earlier, the major factor that determines the role of the fat as a substrate during exercise is its availability to the muscle cell. To be metabolized, triglycerides must be degraded to free fatty acids, 3 molecules, and glycerol, 1 molecule. When triglycerides are split, free fatty acids can be converted into acetyl-CoA and into the Krebs cycle. Which fat stores are used as a fuel source varies as the function of the exercise intensity and duration. For example, plasma fat-free fatty acids, fat-free acids from adipocytes, are the primary source of fat during low intensity exercise. At higher work rates, metabolism muscle triglycerides increases. At exercise intensities between 65 and 85% VO2 max, the contribution of fat as a muscle fuel source is approximately equal between plasma free fatty acids and muscle triglycerides. The contribution of plasma free fatty acids and muscle triglycerides to exercise metabolism during prolonged exercise is summarized in 4.15. Note that at the beginning of exercise, the contribution of plasma free fatty acids and muscle triglycerides is equal. However, as the duration of exercise increases, there is a progressive rise in the role of plasma-free fatty acids as a fuel source. What time we at? 3:52. Sources of protein during exercise. To be used as fuel source, protein must first be degraded into amino acids. Amino acids can be supplied to muscle from the blood or from the amino acid pool in the fiber itself. Again, the role that protein plays as a substrate during exercise is small and is principally dependent on the availability of branched-chain amino acids and the amino acid alanine. Skeletal muscle can directly metabolize branched-chain amino acids, valine, leucine, isoleucine, to produce ATP. Further, in the liver, alanine can be converted to glucose and returned via the blood to skeletal muscles to be utilized as a substrate. Any factor that increases the amino acid pool amount of available amino acids in the liver or in skeletal muscle can be theoretically enhance protein metabolism. One such factor is prolonged exercise, more than 2 hours. Numerous investigators have demonstrated that enzymes capable of degrading muscle proteins, proteases are activated during long-term exercise. The mechanism responsible for activation of these proteases during prolonged exercise appears to be exercise-induced increases in calcium levels within muscle fibers. Indeed, several families of proteases are activated by increases in cellular levels of calcium. As a result of this activation, amino acids are liberated from their parent proteins and increase the use of amino acids as fuel during exercise. Interesting. We'll do this one. Lactate as a fuel source during exercise. For many years, lactate was considered to be a waste product of glycolysis with limited metabolic use. However, new evidence has shown that lactate is not necessarily a waste product, but can play a beneficial role during exercise by serving as both a substrate for the liver to synthesize glucose and as direct fuel source for skeletal muscle and the heart. That is, in slow skeletal muscle fibers and the heart, lactate removed from the blood can be converted to pyruvate, which can then be transformed to acetyl-CoA. The acetyl-CoA can then enter the Krebs cycle and contribute to oxidative metabolism. The concept that lactate can be produced in one tissue and then transported to another to be used as energy source has been termed the lactate shuttle. Hop on the lactate shuttle! This has implications well beyond lactate being used as a fuel or participating in gluconeogenesis. Lactate shuttles have been implicated in the growth of cancer cells. Ooh. See, ask the expert 4.2 for more deals. Oh boy. And so, the regulation of fuel selection during exercise is under complex control and is dependent upon several factors, including diet and intensity and duration of exercise. In general, carbohydrates are used as a major fuel source during high-intensity exercise. During prolonged exercise, there is gradual shift from carbohydrate metabolism toward fat metabolism. Proteins contribute less than 2% of the fuel used during exercise of less than 1 hour's duration. During prolonged exercise, i.e. 3 to 5 hour duration, the total contribution of protein to fuel supply may reach 5 to 10% during the final minutes of prolonged work. Very, very nice. I think we'll look at some pictures. Pictures are good. Alright, see, so what picture we got here? Figure 4.14, influence of exercise intensity on muscle fuel source. Data are from highly trained endurance athletes. Alright, total of fuel source. Alright, exercise intensity. 25% VO2 max. Muscle triglycerides. Going into plasma free fatty acids. To equal 100%, and then a little bit of glucose, plasma glucose, what's in the blood, glucose that's in the blood, and then a little bit of muscle glycogen, very little. Alright, so that looks like 15 to 85% right there. So 85% is from plasma free fat. Alright, 65% of VO2 max. Muscle triglycerides, plasma free fatty acids, a little bit of glucose, but then getting a little more blood glycogen. Alright, 85%. Now that's what I'm talking about. It's somewhat uncomfortable there. Muscle triglycerides, a little bit of plasma free fatty acids, little plasma glucose, and then mostly muscle glycogen. Looks like 40 to 160% muscle glycogen. Alright, and then exercise time per hour, 415. Percentage of energy derived from the four major sources of fuel during some actual exercise, i.e. 65 to 75% VO2 max. Data are used from trained endurance athletes. Alright, exercise time. As time increases, let's just look at 1 hour. 1 hour, percent of energy expenditure. So glycogen, blood glucose. As time increases, muscle glycogen goes down, blood glucose kind of goes up, free fatty acids grows a little bit bigger. I don't like that graph. Alright, we'll hold off there. That's page 82. Sources of fat during exercise, sources of protein during exercise, lactate as a fuel source during exercise, and the summary. We gotta go though. I'll see you later.